Hi, welcome back to Moose in Chemistry. This is Chemical Equilibrium and Ice Tables Lesson C. Alright, again, today we're going to just create the ice tables and we're not going to be solving the problem today. We could be doing these kind of problems in future videos with this particular method. I just think it's really important that we kind of like take small steps in this because this can be intimidating. But, you know, I mean, that's why we should just like, oh, whoa, dog, let's slow down, you know. So anyway, okay. All right, so now what we're going to do is we're going to create an ice table or rice table. I like to use the rice because the R stands for reaction, okay? So now what we're going to do is we're going to set up a table. So we're going to want reaction. And we have 1, 2, 3 items that we're going to be looking at. 3 items, right? So we're going to need 3 columns on top of that. So that's 1 column, 2 columns, and here's our 3rd column. So then we're going to have our initial, so that's our I, and that's our initial information. Then we're going to have what we call the change. How does it change? And that's the C. And then last but not least, we have our equilibrium, which is E. Make it better looking E, although that doesn't look that great either. Alright, so that's how we get rice. If you want to use ice, just erase this right here. This is all you got to do. If you want to call this a rice table, an ice table, you just go goodbye. You know, but I like to put it there. And you don't have to. That's why we call it rice or ice, because everything is nice. Alright, so we're going to call this our reaction. Okay. So now we have our 2 reactants. We have 2H2, and that's a gas, of course. We have O2, and that's also a gas. And we're making water vapor, so that would be, of course, 2H2O, and that's also a gas. So what's our original amounts? Well, according to the problem, we have 0.66 atmospheres of hydrogen. So we're going to go 0.66 ATMs. We have 1.28 atmospheres of oxygen. So we're going to go 1.28 atmospheres of oxygen. You know what? What do we have for our water vapor? Hey, wait a minute. The reaction hasn't occurred yet, right? So our initial amount of water vapor is 0. We don't have any. We have nothing. Okay, now what's our change going to be? So we're going to be losing hydrogen and losing oxygen. So we're going to lose minus 2x. Now we know that minus x was losing, but why is it minus 2x? Because you have a 2 in front of the hydrogen. So when you have a coefficient that's greater than 1, you have to list it there. If it were just 1 like the x is, you would just put minus x. See how easy that is? Now, we are going to be gaining 2 moles of water vapor, right? So we're going to call that positive 2x. Because we're not losing it, we are gaining it. Okay, now, to establish equilibrium, we just have to do a couple more quick things. All we have to do now is to go ahead and go 0.66 minus 2x. 1.28 minus x. And then we just call that 2x. So that's how we set up the original values for this table. You guys be snarly. We'll see you back here at Moose in Chemistry.